Hi, good afternoon. Welcome to the session titled 4 Workflows to Prepare Structural IFC-SG Models for CORENET X Submission. I am Vanessa Tang from AcePLP, and today I am speaking on behalf of buildingSMART Singapore, organizing this event as part of our BIM Interoperability series. Now, buildingSMART is a non-profit organization, and we look specifically at how we could improve data interoperability so data can flow easily from one place to another, from one platform to another. And our goal really is to facilitate the sharing of information to make work processes much more collaborative. And IFC is a format that was also developed by buildingSMART as part of the international chapter. So we are the Singapore chapter of buildingSMART International. And this is why IFC matters to buildingSMART, and this is why we are organizing a series of webinars to support you in your journey to use IFC. All right. So there are a couple of tools that are available under buildingSMART, tools that you can use to improve data interoperability, IFC being one of the tools, right? And as you join us along on these sessions, we will also be introducing more tools for you to explore to facilitate data sharing and interoperability. But today, with Singapore using IFC as the format for submissions to the upcoming CORENET X implementation, the role of buildingSMART Singapore is to provide resources and support to users in Singapore so that, as a community, we all know how to prepare models with good data for submission to CORENET X. And this series is meant to explore different ways that we can use and move information in the BIM models, and specifically in the IFC. And our goal is, of course, to equip everyone within our community with the knowledge to construct quality IFC models for data exchange. Now, the subject of our topic here today is on the various workflows that you can try out to prepare structural IFC-SG models for CORENET X submission. And we've got a couple of speakers lined up for you today. I'm very happy to co-host this session with the Singapore Institute of Building, and coming right up, we will have Dr. Victor Ong to give a few words about this session. Dr. Victor Ong, over to you.
Hey, hello. Thanks, Vanessa. Good afternoon, everyone. Okay, I'm very happy to welcome you to these online seminars for workflow to prepare the structural IFC-SG models for the CORENET X submission. While the webinars basically is aimed to help the qualified person and the BIM manager to meet the CORENET X submission requirement. We are very, very happy for the initiative and support of governments in developing and implementing the CORENET X, whereby qualified person will coordinate the building design upfront and prepare the plan for the building works to be jointly submitted to the authority through the gateway process. Then the authority will jointly review the submissions and issue a consolidated response. Therefore, by minimizing the needs to liaise with the multiple agencies for approval, the new gateway streamlines the entire process and making it more efficient and effective. In addition, the implementation of the BIM models improve the coordination between the building owners, developers, architects, engineers, surveyors, and contractors, fostering a more collaborative environment. So, ladies and gentlemen, this webinar will highlight and share the workflow to prepare the structural IFC-SG models, demonstrating how it can positively impact processes and benefit all stakeholders involved. We, Singapore Institute of Buildings, hope that the new platform and submission system can be adopted by the industries soon as possible, paving the way for a more streamlined and efficient built environment. Thank you, everyone, for joining us, and I look forward to an engaging and productive discussion. Thank you.
All right, thank you, Dr. Victor Ong. Dr. Ong is the immediate past president of Singapore Institute of Building. It's a trade association that represents professionals from all across the built environment. All right, so, and what's joining us all together within the built environment is the use of data, whether it is data for architects or structural engineers, or mechanical engineers, electrical engineers, project managers. So wherever you are in the built environment industry, if you would like to join us and, have more discussions and share knowledge and information, please join us also at the Singapore Institute of Building. Thank you, Dr. Ong. All right. So the next speaker that we have lined up for you today is Engineer Lee Xuan Yan from the Building and Construction Authority. All right, so Xuan Yan is from the Policy and Regulations Department of the Building Engineering Group. She's a senior engineer at BCA, and she's got over 10 years of engineering experience in the built environment sector. And today, she is going to be telling us more about the structural submission process using IFC-SG to CORENET X. She does play a pivotal role in the development of CORENET X, which will be soft launched in mid of December 2023. So that's just 1 month away. So Xuan Yan is here to tell us all about it. Xuan Yan, take us through the submission process for structural engineers, please. Over to you.
Okay, thank you, Vanessa. My name is Xuan Yan. It's from a building engineering group of the BCA. So today I will be sharing about the CORENET X, which is a whole of government project to transform the regulatory approval process for building works. So eventually the presentation, right, will be covered on the overview of the CORENET X, and in particular on how the structural submission are impacted. Without further ado, let me start on the part 1 of the sharing titled Working Together to Prepare the Industry Professional for CORENET X. So for a quick overview, CORENET X is a one-stop integrated digital shopfront that streamlines the regulatory approval for building works. With that, the building design are to be coordinated prior to the submissions, and the agencies will review the model collectively and issue a coordinated response thereafter. A key impetus for change is to the fragmented process, as illustrated in this slide. So the current process requires the architect and engineer to make the regulatory submission to respective agencies separately. There are numerous clearance touchpoints with multiple copies of approved plan by different agencies, which might not tally with one another. So this might lead to conflicting design and hence result in abortive work or resubmission downstream, which will affect the construction productivity. So under the further future investigate workflow, CORENET X will shift the current practice of consultant dealing separately with multiple agencies to one where the consultant will come together, collaborate upfront to harmonize their design and produce one coordinated BIM model for approval. So the building project will no longer need to go through more than 20 approval gateways as per today. Instead, we will streamline the process to only 3 main gateways, namely the design gateway, construction gateway, and completion gateway, with an optional piling gateway. Okay, I will elaborate further on the new regulatory gateway in the next 2 slides. So the first gateway is on design gateway. It's for the clearance of key design parameter before the project team could proceed to with their detailed design. Thereafter, the project team can either go directly to the construction gateway or opt in for optional piling gateway to expedite the commencement of the substructure work. However, for projects that opt in for the piling gateway, the QP must assess the risk of starting on piling before the superstructure design is firmed up and make sure it does not lead to any non-compliances at subsequent gateways. So the QP should not quote, piling has commenced as a reason for waiver. So for the second gateway, construction gateway, is a clearance of detailed design that need to be coordinated to minimize the abortive work downstream. So for other agency-specific requirements that have no implication across disciplines or agencies, independent submissions can be made to the specific agencies itself. Last but not least, akin to today's TOP or CSC, the completion gateway is to ensure the building work are constructed in accordance with the approved plans. So for simpler design, like individual landed buildings or standalone linkway, we are working out an even more streamlined process, which will combine the design and construction gateway into a single stage, which is so-called a direct submission process. So to onboard the industry progressively, the CorEnet X will be implemented in phases to ensure a smooth transition. So the first phase will begin with a soft launch in December 2023. The CorEnet X will start to receiving the submission on a voluntary basis for a year to allow the industry to familiarize with the new platform and processes. So from 1st April 2025 onwards, it would be mandatory for all the submission to be met through the CorEnet X and followed by the onboarding of ongoing project in 2026. So you can find more details on the CorEnet X submission process through the link and the QR code shown in the slide. Without further ado, let's move on to the second section on how the industry can get ready for the structural submission for CorEnet X. As shared earlier, CorEnet X got three main gateways, which are design gateway, construction gateway, and completion gateway, which in addition to piling gateway, which is optional. So the three gateway approval process will be the default workflow for all the new projects. So with this new regulatory framework, the industry will need to submit their structural design for construction gateway together with architectural design in a coordinated submission, which will be processed by all the agencies simultaneously. So the project team can also choose to split the piling submission from overall coordinated submission and submit at piling gateway so that they may commence the piling works earlier while they are still seeking the regulatory approval at construction gateway. So for independent submissions with no dependency on other agencies' clearance, for example, the demolition, ERSS, temporary traffic decking, cladding, and barrier works, the project team can submit the design details separately based on their project timeline outside the main gateway. Besides, the project team shall pre-consult the BCA on their complex structure design prior to piling gateway and construction gateway. The project team will need to include the completion letter of the pre-consultation at the piling gateway and construction gateway submission. Next, let's move on to the scope of the structural work. The piling gateway clearance is for the design of permanent piling and substructural works which do not affect the internal layout as shown in the diagram. So the approval package of the piling gateway will consist of BCA ST approval on piling and foundation works, as well as LTA in principle approval for PAR design and PAR layout plan if the project is within a railway protection zone. So the structural work allowed to be submitted in piling gateway for conventional foundation systems are piling, parquet or footing, and substructure that are in contact with ground. So for basement construction, only diaphragm wall and base slab of the basement with bottom-up construction are allowed to be submitted in the piling gateway. So for basement with top-down construction, the project team can submit the diaphragm wall, slab, and temporary columns in the piling gateway. Please note that any permanent structure required to be included in the piling gateways, the QP must ensure that their work will not lead to non-compliances later on. So the waiver for non-compliances at construction gateway will not be acceded to if the reason quoted is due to constraint from the permanent structure that has been approved in piling gateway. So this table summarizes the structural submission package required for CorEnet X for ease of reference. So in piling and superstructure submission, the project team will need to submit a set of IFC-SG model and substantiate with 2D supplementary drawing, together with design calculation report and references needed as shown in the table. Basically, The submission package for structural submission is still largely the same as current SD submission, except for the drawing deliverables. The current drawing deliverables consist of 3D DWF file and 2D drawings will be replaced by IFC-SG model, which is a platform and software neutral format that can be easily accessed and opened, while the model can be viewed in both 3D and 2D. So during the transition, we'll be allowed for 2D supplementary drawing for general notes and special details such as slab reinforcement, the complex structure detailing, the precast, PT details, and steel connections. So at completion gateway, the project team will still need to submit the complete set of the SIBL IFC-SG model and substantiate with 2D supplementary drawing together with the design calculation report if needed. So the certification of supervision for piling works and structural works are required to be submitted as well. For independent submission, such as demolition, ERSS, cladding, and barrier, the IFC-SG model is not compulsory. However, the submission content need to be cross-referenced in the structural IFC-SG model for the agency processing officer to locate it inside the model. All such requirements of the submission package has been stipulated in the code of practice, which has been published in the CORENET X website. So a complete set of the structural IFC-SG model shall consist of the elements such as the piles, footing or parquets, beam, column, wall, slab, staircase, or boreholes. All these elements shall be modeled based on the actual geometry and georeference. All the IFC-SG parameters shall follow the standard naming and units as stipulated in our code practice. So the screenshot shown in this slide are from one IFC-SG model with the standardized IFC-SG parameters incorporated. The properties panel of the piles and beam elements shows the specification and details needed for the regulatory review, where the agencies can access the model directly. So with that, the QPs and the teams will no longer need to annotate these properties and information on the 2D plans. This can further reduce the manual annotation work from the QP ends. So we have published a code practice in September 2023 to guide the industry on how to work out the submission for CORENET X. So the link of the code practice is attached here. Section 4 of the code practice stipulates the beam data representation, which is of IFC-SG. And also the modeling good practices. So all the IFC-SG parameters needed for IFC-SG model has been clearly defined in the code practice. So in future, the modeler will generate the schedules in the beam authoring tools and export to Excel for the engineer's input. The engineer will then write in the design outcome in the Excel and allow for imports to the beam authoring tools. And thereafter, the engineer can navigate and check on the accuracy of the data transfer into the beam model or IFC-SG model with the free viewer. This means the engineer would need to work closely with the modeler for modeling and design output checking in the futures. So let's watch a video on how we anticipate the industry to input the design information into the native model. This video is an example on how the industry is able to transfer their design data into beam authoring software using a free plugin. Yeah, this model has been doing inside the Autodesk Revit, and all the parameters is in empty field now. So we can see that the schedule here all is just having the mark and also the family type. All the other IC parameter field is still in blank. So the modeler has prepared a lot of the schedules for the engineer to input, and he made use of the D-Routes link to export the schedule out to Excel. So it's a very easy and also user-friendly workout. Okay, while waiting for the Excel to be exported. So you can see it's still the same as the schedule that we saw inside the Revit. So your engineer should input all the design data inside here. So to import the design data, we have prepared a set of the design inputs inside the Excel as well. Okay, so we want to import all this design information into the BIM model. Okay. So with the same interface, it's just click on the import, then the import from Excel. Then you just choose the Excel file with the design input. So it will automatically to update all the design information inside the BIM model. Eventually, this D-Root plugin is a free plugin that is available for all the Autodesk Revit users. So you can see all the Excels and also the schedule. All the schedule and input has been all filled up, and all the data has been successfully transferred inside the BIM model easily. Yeah, so should you require any further clarification, so you may submit your query at the CORENET X inquiry using the link shown below. So please feel free to explore all these regarding CORENET X and get your team to ready for the CORENET X by end of 2023. Yeah, thank you.
Thank you very
Vanessa,
much. Thank you, Engineer Xuan Yan. All right, so we've got a question coming from WS, and we'll take this right away because I think it's very relevant to the presentation that you have, and what our subsequent presenters are going to talk about, which is how data is going to be moved within their respective software environments. Now, the question from WS is, how do you transfer this information to the site team?
Eventually, how we're going to transfer all this kind of information to the site team, right? Because all these so-called IFC-SG model is purely for the regulatory approval. So if we are not stopping the consultant to put it in the 2D drawing or any of the drawing form to convey the message or convey the design output to the site team. So eventually the consultant will be still able to do so-called the drawing at their own to share the information to the contractors or anyone that they like. Yeah, we hope it answer the questions.
Yeah, Xuan Yan, thank you. So the preparation of the IFC-SG models is for submission to CORENET X. So if you are sharing information with your site teams, that will be done within the respective software environments. And that is exactly what we have lined up for you. So that I thought that was a great question to kickstart the next segment of the presentation, which is that we would have 4 speakers, one from each team, first from Trimble, and then from Autodesk, and then Bentley and Graphisoft. So if you are staying on for the rest, of the session, you will be seeing this, in quick succession. All right, so let's move on to our first software presenter then, and that's Loon, who is a senior technical consultant at Trimble Solutions. He's got 14 years of experience in Tekla solutions analysis and design functions, and he usually provides the training and technical support to end users of Tekla software. So here to tell us more today about how you can move data in and out of analysis and design tools within the Trimble platforms is Loon. And Loon, over to you.
Good afternoon, everyone. Welcome to this session for the Trimble workflow from Tekla Structural Designer to IFC-SG. Again, my name is Loon from Trimble Solutions, Southeast Asia. I'm a senior technical consultant. So today we'll walk through the Trimble workflow from Tekla Structural Designer to IFC-SG. Okay, so on today's agenda, we'll give you an overview of digitalized workflow, and followed by how to prepare the analysis and design data, load and analyze the design, and followed by how you can do the georeferencing in the Trimble products, followed by how you can integrate your design data and the BIM tools. Lastly, you can also use our tools to view and also check the compliance to the CORENET X code of practice to ensure that what the IFC-SG submitted models is compliant to the code of practice by the BCA. Okay, so overview itself for the digitalized workflow. This is the current structural submissions for the CORENET X, and where you may start with the BIM tools. And from the BIM tools itself, you can get any A&D solutions into our BIM tools, or alternative, if you do not have any analysis and design solution, you may get the IFC model directly to the BIM tools, BIM authoring tools. And from there itself, you'll be going to export to IFC model. And from there, using our free viewer, IFC viewer, to view it. And in the same time, also upon using the viewer, this will also allow you to check the model. We have free tools to check on the data, ensure that it is properly populated according to code of practice, and before you submit to the CORENET X portal. Okay, so next we'll take a look on the how you can prepare your analysis and design data, load analysis and design. And as an engineer, you can start with the analysis and design tools. So in this presentation itself, it will be using the Tekla Structural Designer. So some of the highlights of these solutions itself, TSD enable user to automate the bin loadings. Okay, and also apply to the structures according to code compliance, and you will be able to view the bin loadings followed by the automated pattern loadings to the code requirement, and you can apply easily, very automated to the model. And oops, just a minute. Okay, so after that, the automated, then we do have the seismic wizards also allow you to input to the model, then very quickly. Then from there, you can proceed to do the analysis and design, and followed by the design and also generating the drawing in the model. Okay, and populate from the design from top to the roof. Okay, next one is we will going to take a look on the how you can integrate the design data to the BIM. And in this process itself, we're coming through from analysis and solutions to the BIM tools. And we take a look on how we can do it. So firstly, we'll complete the design in the Tekla Structural Designer, so ensure everything is done. Then from there itself, you can easily use the import tools to the Tekla Structural Designer. Import in, you can import with the mapping files to ensure that all the data section is properly populated and together with the rebar into the model. So it take a while, and also we do have the model comparison tools to ensure that everything is comparable. So we start to process the rebars, and then it will importing all the details together with the design into the model. Okay, so everything will be imported, including the rebars. And next thing itself, from the design tools itself, we have a so-called extractor, which is the free tools and developed by Trimble, and where you can actually use that to generate all your design data. Okay, it will actually populate to the Excel format. You don't need to do any extra step, just need to click the tools and you start to populate all your design data into the spreadsheet. Okay, then you can start to use this data to import to the BIM tools. Okay, we'll move on to the next one. So before we start to import the design data, we take a look on how you can set up the georeferencing into the model. Okay, so firstly, once you have these models done, we can quickly define the base point using the project property into the Tekla structures. So in this case itself, we can put in the data and also following the coordinate system SVY21 and modify the base point and define where your base point of these structures. So ensure that everything is according to the definitions of the georeferencings. So you can close it, and then you can also save it this georeferencing for future usage. So everything will be able to set it accordingly. So once done, you can save it. And upon that, then you can actually export it to the IFC-SG formats also for these georeferencing. So you can use back. So and make sure that when you export your IFC-SG model, you'll be following the correct georeferencings. Okay. So moving forward, Cecile, then we can actually view the IFC model that you have created and also check according to the CORENET X code of practice. Okay, so previously we have A&D solutions and the IFC. So just now we go through the path which is A&D solutions and go through here, and then to the Tekla structures, the BIM tools. And next thing is how these steps we're going to export to IFC, and then you can view it for the IFC viewables itself. Okay, so next thing is how you remember just now we have already have the Excel file, so you need to key in manually. So what you need to do, you just currently is empty on all the spaces itself. So we have created a tools again, a free plugin from Trimble that you can actually import the Excel file. Okay, so import Excel file created by the extractor. So you can load in any settings. So currently there is some default setting where you can actually automated map everything. So you can create your own header, not necessary to be following this header. So everything will be flexible that you can import everything into your BIM tools. So we start to finding the elements and try to map accordingly. So at this, oops, back. Oops, again, I put this minute. Sorry. Okay, so just now we have here, and you can see all the GUID will be actually mapping together. And then from there yourself, you can save to the model. So once you save to the model, everything will be automated. And then if you check the elements itself, you can see all the information will be populated. Okay, so of course there is some of the empty elements itself because some of the data may not be from design tools. So you still can use the Excel format to fill in accordingly. Okay, so but basically most of the design data is automated. You can see the rebar, everything will be automated, populated using the importer. So once everything is done, then you can actually start to export your model, the BIM tools models, and export it to the IFC model. Okay, start to key in the names that you want to the IFC SG format. So you can choose which to export. So what is the element? So once done, you can quickly export. Then from there itself, you will see IFC workflow files to created, and you can quickly view it in our free BIM tools, Trimble Connect web-based, that you can view the model directly. It's a web-based, so we can see this slowly converting all these files. So you can see exactly the same that on here. Okay, so everything will be imported or so-called exported to the IFC-SG format. So next thing is once it's done, of course, we do provide additional free tools for you to identify or to explore the model. Okay, So after we're done the submissions, after we done the exported to IFC, and then we do provide you an additional step for you to check to ensure that your data is correct. Okay, so a quick one on this, we have a Model Explorer, where once you have launched up these tools itself from the Trimble Connect, or we so-called the free IFC viewer, you will able to see the model, and it's actually filtered by the level, so you can easily see by the level and also by element. Okay, so you can browse through the elements itself, and also you can click to select whichever member you want. Okay, so all these members itself, you're able to zoom it, to isolate, and also to hide the member. Okay, unhide and refresh the thing, and also you can select to refresh the view. Okay, same thing is also you can select the member from the model. So it actually quickly browse you to the member. So you can see this case itself, you will highlight the C51, and also in the same time, the property also called IFC-SG UDA itself will be populated into this table. So easily for you to explore the models. Okay, and you also can separate it to do a search. In this case itself, you can search with a comma, then you can search more items in the viewer, so then you can identify them in the models. Okay. So next thing is how we have, as mentioned, we have IFC-SG model checker that allow you to check the model and ensure that all the data is properly populated. So in this case itself, let's say we have filtered up to the level 1, and says I just want to check for the level 1 and ensure that whether this is correctly populated. We can check for the selected. Okay, and then once we have checked it, then you can see all the members itself will be give you the rules, and all these rules itself well defined according to the code of practice from the BCA. So it tell you that which elements is missing. So you see IFC elements assembly, there's missing data, and also the reinforcement bar, there's a missing data on that particular. So let's say we browse to the beams itself, the column, you can see there's something warning that is may require to give you a warning. So you can also select the items and also check on the splice distill, and also everything you can also zoom to the selections and hide it and isolate the member so that you can do a transparency. Okay, and then from there itself, you're able to isolate this member. Okay, so let's say next thing itself, we take a look on the beams itself. Let's say in this case itself, we can see there's some arrows on the construction method, which means that some of the things that require and is empty. So we need to do some things on that. So we can actually select them in the Trimble Connect, and then we can isolate them so that you can do some to-do list to tell the so-called the end user or the so-called the modeler, hey, there's something missing on the data itself. So you can actually tell them. So in this case itself, because there is no data to identify which marking, so we can also put in some marks on that. Okay, so in this data itself, we can provide some marking so that we can help the engineers to know which marking is missing, or the so-called modeler, whichever we use data. So again, you can see here, from there, we can identify, okay, this is 2B, 25, 51, and all these beam data is missing. So, and from there itself, we can quickly export it to the Excel file as an arrow file. Okay, so we can save it as arrow file. So let's just quickly browse through this one. There's some time. Okay, so we can, from there itself, our IFC viewer, we have some tools for you to do the collaborations. So you can add in some to-do to tell whichever that is supposed to be follow up. And then we can attach, say, a priority and create a to-do list. And this one also, we can attach the file to it. And then from there itself, you have the arrow file, and you start to create it and save it. Once you save it, you will create a to-do and send an email to the particular person. Okay. So from here itself, you can see there will be an email located to that and take you together with the Excel. So from the Excel itself, you can download it from the to-do for whoever who received the to-do itself. And then from the to-do, from the Excel itself, we can download and we can identify all the ID from there, and we can mix a join and copy all the ID. And from this ID itself, we can quickly go back to our Tekla structures. In this case itself, will be select by identifier. So you can select all the beams, and from here itself, you can actually update it. So in this case itself, we choose it as a cast in situ, so which is a concrete in this case. So we can modify it, and again, we quickly do updates to the IFC model. So we do export. So let's say this case itself, we export again to update the file. Let's just quickly fast forward on that due to the time. Okay, so from here itself, we quickly updates it. And then after you update the model, and then from here, you can view the model. And quickly you use back the same tools to do the IFC model checker. And from here itself, I think it takes a while. Okay, so we can check on the beams itself. You can see no longer have any arrows on the construction site's values itself. Okay, so besides that, so let's say you have the Tekla structures in the same machines itself, you can also use this tool to quickly directly select it. So you can actually right click on it, and from the Tekla structure itself, you can actually right click on this IFC viewer checker. So right click the pen and go for Tekla structures, select in models, then you can quickly select it into it, and then no need to. So previous work steps itself basically is because you may not have the same Tekla structure software in the machines, then you may need to use that way. Otherwise, you can use to directly select in using the Trimble Connect checkers. Okay, so just to emphasize or recap again on the Trimble Connect X workflow. So from the A&D solution, in this case itself will be Tekla Structure Designer, and then you get all the design done. Then you can populate to our beam authoring tools itself, which is Tekla Structures. And as I mentioned just now, someone have asked a question on the sites itself. So in Tekla Structures, so we do have additional things that where you can put in the connection and even generate the rebar details. So from there, you can get your fabrication drawing or even construction drawing, shop drawings itself. Then from there, you can populate the details to the Trimble Connects, and then followed by, after that, you can do the submissions to the Connects submissions itself. Okay, so from there itself, we have a resource center where you can get from this website. Okay, so everything will have give you the how the ecosystem works, and also all the free tools developed by Trimble you can get from there. Okay, so a quick ones in case you are interested on our Trimble workflow from Tekla Structure Designer to the IFC. So do register for the CorEx Accelerator program developed for the user to join, so that you will be facilitate easier for you to use our workflow. Okay, so it's to educate and support the BIM teams in the CNS offices. So basically, this will be a 30 days programs, and open registrations start from the 3rd of November. And for CNS consultant, BIM consultant, and also contractor. Okay, I think that's all for my sites. I think a bit delayed slightly. Okay, so that's all from mine. Pass over to Vanessa.
Thank you, Loon. And you know, bringing it back again to WS's question about how the site teams can communicate. A lot of the communication will be through Trimble Connect.
Yes, and also Tekla structures, both.
Okay, all right. Well, thank you very much, Loon, for showing us, you know, the data flows and the communications through the Tekla suite of products. Let's now turn our attention to another set of workflows from Autodesk, and this is going to be presented by Sagar Thorat. Everybody knows Sagar. I go to Sagar with all my questions, my technical questions as well. So you want to find his LinkedIn profile so you can ask him questions there as well. All right, Sagar. Over to you now. Can you tell us more about the Autodesk solutions for structural engineers and their BIM teams, please? Sagar, over to you.
Absolutely, and thank you, Vanessa, and good afternoon to everyone. So let's begin with this. So robot structure analysis is our flagship sort of structural analysis program, and it integrates very well with Revit, through which you will be doing the IFC-SG export and submissions, and that's what we are targeting. I'm Sagar Thorat. I'm an architectural engineer and working as a technical solutions executive at Autodesk Singapore. So first up, we will understand how robot structural analysis works very briefly, understand the robot and Revit analysis link. Then we will understand Revit analytical model automation, which is sort of an AI-driven approach that we are building up, by which you can actually quickly enable model-driven automation for analytics as well. And then finally, we'll be going into populating of IFC-SG parameters through Revit, and then the IFC4 classification, and we'll go into the export of the IFC-SG model, right? So to begin with, Robot is a fully functional structural analysis package. And in Singapore, the usage of Robot is by some of our leading clients like Meinhardt and so on, and Arup as well. So model definitions, load definitions, analysis, documents, and code checking can be done using Robot. So we won't be going into details of Robot, but if you would like to learn more on Robot, there's a lot of information that can be obtained on YouTube or on our platforms as well, right? With the Autodesk so in general, Robot allows you to sort of build your entire structural models, as well as define loads, do analysis, documentation, and code checking as well. And you can actually begin by populating different load cases. You can also explore conditions. So we'll actually try to do this through a quick live demo. Yeah. So I won't go into details of these, but Robot does consist of all the codes that are necessary for Singapore engineers to design their buildings. Yeah. Again, Robot has been utilized on MRT stations in Singapore by Meinhardt, and there are other companies which are also using Robot for their structure analysis for buildings. Right. So there's a full recommended sort of a workflow between Revit and Robot, and why this is important, because you would want to sort of work with the best in BIM authoring together with the analysis package, and where you want interoperability at a very higher degree is where Robot and Revit comes into picture, right? And we have upgraded this workflow every now and then. Not going into a lot of details, but if you'd like to learn more, there's a lot of resources available which you can go through. Now, the key area for us to look at today is how Robot models can go into Revit and Revit can go into Robot, and how they can seamlessly integrate with some caveats, but they work quite well together. The data can be exchanged quite well between the two, right? So let's try and quickly understand. Yeah. So I thought maybe giving you a quick demo would also help. So this is Robot, right? And I have loads, geometry, members, nodes, all of this a normal structural package would have. I'm just going to quickly run my analysis, right? And I can look at results over here. So Robot can sort of give me those results and different ways of viewing. So all of this can be done inside Robot, okay? So you can fully have a look at your design and look at the bending moments and look at, for example, different reactions, different forces. All of this you can take care of and design a fully fledged building using Robot. Yeah. Also looking at FX, FY, different moment reactions. All of these you can use Robot for, and you can quickly generate your structural designs. Now, most important for us to understand is, if I am in Revit now, I literally have nothing, right? There is no model in Revit. It's a blank slate, right? This is a blank model. Okay. I've just opened a structural template in Revit. So I'm going to go to Analyze, and under Analyze, I have this Robot Structure Analysis, sort of an analysis link plugin, and I'm going to pull the model from Robot. I don't have anything today, right? I'm actually going to pull the model from my structural engineer and simply update the model with a direct link and just wait for like, because it's a small model, it's going to take few seconds. Large models might take few minutes, but it's quite a quick process to bring in your models. Yeah. So I've brought in my analysis model here, exactly the model that was in Robot. And mind you, there are no members, right? So this is something new in Revit where you do not have to really model your beams and columns, but you can just work with analytics, right? There's only analytical models and nodes that you can straight away use. Now, the best part is that if I want to concretize this model, I can go and do a analytical automation, right? Analytical to physical automation, physical to analytical automation. And this is again generative design. So I'm going to select all of this data, all of these models, enter, and I can now select. You see that 23 elements have been selected, and I'm going to run this, and you can see that my concrete elements as well as my steel elements have been generated. Okay. So now if I look at the materials itself, you can see that these are pure Revit objects, right? Revit entities where I can go and start applying new materials, for example, right? I can start adding materials here and I can start moving around, and this is pure Revit data. There's no need to modify anything. It is a straight import from Robot without you really exporting or importing anything, right? But if I now click on the column and I go to my properties, I actually do not have any parameters. The IFC parameters are empty. There's nothing in here, but I can start populating these parameters now. And in order for me to start populating those parameters, I can go to the interoperability tools. Now the Autodesk interoperability tools can be downloaded for 5 versions of Revit: 2024, 2023, 2022, 2021, and 2020. And you can actually download that from your Autodesk account. If you log into your Autodesk account under products and services, you can actually search for Revit and download the Autodesk interoperability tools. Now it's important for you to know this, because without Autodesk interoperability tools, you will sort of spend a lot of time with shared parameters, and a faster workflow is through Autodesk interoperability tools, which are always up to date, and you can download the latest versions from your manage.autodesk.com. So here, for example, if I search for Revit right now, I can go to the details, and you can see that for the 4 versions here, I go to the extensions and I can go and download my interoperability tools straight away from here, right? So take note of this. It's quite important that you actually download these and the latest versions all the time. And you can download them for 2023, 2022, and 2021, and also request to download for 2020. However, it's advisable to stick to 2021 and above versions, right? So here again, under extensions, you can see that the interoperability tools are agnostic to the version. So you don't have to worry about the versioning. Yeah, the interoperability tools will work for the current -3 versions of Revit. Okay. Now, going back to the model itself in Revit, I'm within Revit right now, and I'm going to use the interoperability tools to sort of run the CORENET X file. So we have the CORENET X file right within here within the interoperability tools, and you can update, and you can see that the parameters, the IFC-SG parameters. So we are using the sandbox industry mapping file, which has only 175 parameters, but we will be updating this file on November the 27th, and you can download the latest IFC-SG configuration file and shared parameters file from this website, which is interoperability.autodesk.com. It's a dedicated web page for CORENET X, and you can download the share parameters tool configuration file, model checker check set, shared parameters file, and shared parameters by discipline from this website. So November 27th, you will be able to download the latest industry mapping file that is provided by BCA. Yeah. So let's go back to Revit now. After the parameters that have been populated, what you will see that now if I click on my column and I scroll down, you will see that all the IFC-SG parameters that I need to populate are over here. Yeah, it's all in there. And now let's say I actually just model another column, or if I just model another beam, it automatically templatizes, right? So I can sort of make a beam here, right? And you can see that automatically all the IFC-SG parameters are populated. You do not have to go to interoperability tools and run it again. It now creates a template for you by default. Once you run it, you don't have to run it again, right? And this is a beautiful thing about the interoperability tools, that this automation, you do not have to again go and do shared parameters. Okay, so make sure you use the Autodesk interoperability tools to populate the parameters. We are not going into the values. Okay, the earlier example that was shown on die roots is a great example of how you can actually populate the values. So go ahead and use that tool. Die roots is a great tool. They are Autodesk partners and they are always updating their solutions. So die roots is a great platform for you to start populating the values, your structural values. But when it goes to parameters and classification, you would have to use the Autodesk interoperability tools. So when it comes to classification, now you can actually assign the IFC4 classifications. So here we have uniclass, omniclass, as well as the IFC, which I'm going to load, IFC4. And here I'm actually just going to select all of these columns, and I think selection procedures are known by everybody, so I'm not going to go through those. I'm just going to select columns, apply them, and say OK, and you can see that it'll automatically track and take me to the correct IFC class of the column, and I can choose the subclass if there is one available. In this case, I'm just going to assign the IFC column, and that's it. Once I assign this, it'll automatically have the IFC4 classification notified exactly over here. Okay, so you can see that the IFC4 classification has been automatically assigned to the column, right? And then you can do so for all the beams, you can do so for all the slabs and so on, right? And here is the classification, which is the IFC export as. Right, now the great thing about this is that now if I go back to robot, right, and if I do any changes at all, right, let's say I want to add a geometry, I want to add a member here, so I'm going to sort of add a structural member right in here, and let's just quickly go in, add it here. Okay, and there you go. I've added a new beam, so I won't go into details of it, but I'll keep that new beam. And if I now go back to Revit, right, and let's go to the analytical model here, and then analyze, and under the plugin I can run the plugin once again, update model and results, and once I update the model and results, the new data, right, the new beam or the new column or the new slab should automatically appear. There you go, right? So you do not have to worry about export and import anymore. There's a direct link, it's an analytical link, and I can go to analyzing and straight away update my model by doing analytical to physical update by simply selecting the new element that we got in, going back to the analytical automation and running, and you will see that the 3D model, the new beam has been updated. That's it, right? And that's beautiful. This is really something which has been sorted from Revit 2023 onwards. Previously, this workflow was not so smooth, but now there's a direct data exchange, an analytical and physical model data exchange between Robot and Revit, right? You can push data across both the softwares. Now let's push data from Revit back to Robot, right? So let's say, for example, I'm going to level 1 over here, and here I'm going to sort of do a structural wall, right? I'll just model a structural wall here. I'm just going to do it randomly for now. In the 3D view, I have the model here, right? And I'm just going to sort of add and update this up to level 2 and then 0. And then I should have my wall there, right? And then I can go to analyze, and here in the analytical automation, I can do a physical to analytical for the building, right? So I do a physical to analytical, select the data that I have, right? Let me just select this as well, select, right? And once I've selected all of this data, just go in there, run, And you can see that my analytical model for these walls has also been updated, right? There's new analytical data here. Now I can actually send this data to Robot, right? In Robot, I actually do not have these here right now. And I can actually now go back to Revit and run the Robot analysis link and send the model. So this time I'm going to send the model, right? And let's just send the model across. And any changes that you make in Revit should ideally be reflected within Robot as well. Yeah. So anything that you add new, you can see I've automatically transferred the data, and that's what we are all looking for, right? The best of the BIM and the best of the analysis can come together for you to quickly analyze this data and then again run the calculations. And then of course I haven't applied any loads, but without loads the wall still carries its dead load, and I can run through my analysis once again and run through the MYMX and the forces over here, right? And that's it. So that's how quick it can be. Yeah, of course, if it's a small model. Right, there you go. And now we are at the 3D model here. We are going to sort of look at the wall, and you can see that without me doing anything, automatically all the IFC-SG parameters are assigned to this wall. That's it, right? And that's because of this interoperability tools. And now once you have sort of bought in the IFC-SG parameters, you can now also run a check whether the parameters are there, whether the values are there, whether the classification is correct, right? Because if you look at the wall, I'm just going to quickly check. You see that the IFC export as parameter is not filled in. And this is a crucial step. Without you classifying your IFC to IFC4, you will not be able to export the IFC-SG parameters. So let's look at the classification once again, right? And this time I'm just going to select my wall. I can select as I am looking at it. Okay. Hey, Vanessa, I have time, right? I think, yeah, I have some five more minutes. So I can choose the wall here, and under the wall, I can say that this is a wall, which is a shear wall, right? And then assign it. And once I have assigned this, now you can go ahead and export this data out. Now the values you can fill in, right? You can fill in these values, which is what you can use die roots for, or you can use Revit values as well. So once you have this data in, let's go ahead and do the final step, which is going to be, oh, sorry, but before that, we are going to run the checker, right? So far, there is no configuration file setup. So I'm going to use the IFC-SG schema model validation, and you can see the CORENET X logo over here. The last it was updated in May, but we're going to update it in November soon. And then you can say, okay, and now I can run a check for Revit 2023 structural elements only. And I'm going to save this, right? Save and close. And I'm going to add the models, all the models that I have, and run the report. Okay. I'll run the model checker report. Now remember, this model checker is only to check whether the correct classification and the correct parameters have been assigned or not. Okay. And that's all it checks, correct? So I've got a 0% here, but I need to check why that was so. I think it's because probably there are no values in there. But again, this is a good way for you to check whether the classifications have been assigned or not, right? And you can quickly have a look at these as well. So that's the model checker and how you can assign it. So say, for example, you look at the beam, there is the classification. And of course, there is classification for the walls. The beams currently does not have a classification. So I have to go ahead and select all these beams over here, right? And we just go ahead and do the filter selection, which will be faster. Check none, just do the structural framing, apply, and then go to interoperability tools, assign the classification, right? And here you can see it automatically takes you to beam, and I can choose IFC beam, assign the classification, and there you go. Okay, so here you go. We have the classification now. The properties, the parameters for the beam are also in. And now let's go ahead and take the final step, which is to export the IFC model, right? And here we will use the IFC-SG export setup. You can also import this setup through the JSON file that BCA provides. So you can just go in, modify the setup. You can bring in the JSON file, or you can, because we already have this in here, you can see that the SPY21 coordinate system is clear, the general annotation, the content, and here we have the property sets for the IFC-SG, which is mapped to the model as well. So here I can just click OK and save this in a particular place. So let's go to buildingSMART, Revit IFC-SG. I'm just going to say it as sample structure. Okay, save. And we are going to export this out. So let's export this out. Right. It's going to take like a few seconds. And there you go. You should have exported this out. And I'm going to go and open the Open IFC Viewer. This is a free IFC Viewer by Open Design Alliance. And you can also use other IFC viewers, but in this case, I'm just going to use this one. It's a small model. So there you go. You have your IFC file, and you also have all your classifications in there. P-sets are in there, and all the IFC values are also in there, right? And you should also have them for your, you can see the P-set beam, the net surface, so on, as well as for your columns and beams. All the IFC objects are there. Okay. All right. So I'll move back to the presentation now. So we had a look at the analytical model definitions. Let me just resume the slideshow. Sorry.
And we'll do need to wrap up quite soon.
Yeah, I'm done. I'm almost done. Okay. So I think I need to close the analytical automation. There you go. So we have looked at how Robot and Revit can seamlessly interoperate and how the data can be exchanged between the both. And the Autodesk interoperability tools is the most important thing you need to know, which you have to download. It's a free tool and it's agnostic to the Revit versions for the last 4 or 5 versions. So please use those. And apparently what you need is the shared parameter tool, the standardized data tool, and the model checker check set. And these are the steps, I think, which we have taken. You can also use best practices, Revit health checks as part of the interoperability tools to sort of sanitize your models before you really go into exporting. Yeah. And the 5 steps for exporting your IFC-SG are adding parameters, populating the IFC classes, and validation and population and export. Right. And we have run through the demonstration. So I'm just going to straight away move to the website. This is the QR code for the website where you will find the latest data. So November 27th, we will be updating to the latest intro industry mapping file by BCA and some more learning resources. And of course, you can always email me and my colleague John Rivas or Karen Lowe or Ken So. The entire Autodesk team over here is to help you. And yeah, we'll partner with you to make you more successful on CORENET X. Yeah, thank you. Thank you very much.
Thank you, Sagar. And of course, we've also covered the interoperability tools offered by Autodesk in the first episode of the BIM Interoperability series. So you can go on down to the buildingSMART Singapore's YouTube channel, and that's where you can dive into further details about what Sagar has presented the first time around. All right, Sagar, we've got some questions for you in the Q&A section. So because we're pressed for time, we're going to move ahead with Junior's presentation, and I'll leave you to address the question that's in the Q&A. Now, Junior's is our next speaker. He's representing Bentley Systems. He's an application engineer for solution engineering and a professional engineer that has designed and constructed various types of real estate and industrial solutions across Indonesia. And today he's going to tell us more about the Bentley workflow, specifically how we move data from StatPro to open buildings and into IFC. Juniors, over to you.
Thank you, Vanessa. As mentioned before, in the topic, we are we are talking about the structural flow with the IFC-SG. So I would like to take the this moment actually to share how we can do the structural workload inside Bentley. So my name is Junius. So I'm a professional structural engineer as well. So I'm would like to highlight. I would like to highlight what is the typical works that I used to do as a structural engineer or structural designers. So of course we do have the structural analysis. So in Bentley we can use the Start Pro, and we can use also Plaxis for the substructures for geotechnical. And of course we do have like a connections analysis with ROMs, and we are moving forward to have the structural beam modelings with open buildings. And of course, in the open buildings, we can proceed for the submissions with the IFC-SG. And I would like also to cover a bit regarding the detailing engineering that we can do inside the Bentley ecosystems. So those three things actually I can say this is like a bundle if you're working in the building structure. So we do have the interoperability workflow on how we can communicate from each platform. So let's say you are starting with Start and bringing all the structural analytical models or structural physical model into the open buildings. And then you can do also the detailings after you are doing the analysis. So this interoperability facilitates with what we call the integrated structural modeling. So we can create or we can export a file we call integrated structural modeling or ISM. So the formatted ISM.djns, you can export from Start, open buildings, or pro structures, and then you can import as well, doing the communications by editing or adding some changes in the structure. You can do it and push or update the structure into the ISM.djn to be able to be seen in another applications. So this collaborations actually it's powered with the iTwin services right now. So Bentley have the iTwin services. So I would say it's not only limited to these three products, but all Bentley applications can work around with these ecosystems using these iTwin services. But since we are focusing on what structural engineer can do, so I'm trying to start with Start Pro. Okay, so right now I'm opening the Start Pro. So I do have like a typical commercial building structure that already set up here. So I already assigned also the sections and everything, also the loads. So from these models, I can go to the iTwin services have here, and then we can create the file, what we call the ISM file. So we can just create the new files. You can just choose wherever locations you wish to store it. And I can just continue to push the structure from Start. Okay. So this process, when exporting, it will taking some time, depends of the model size. So it will bring you to verify the model using the iTwin Analytical Synchronizer. This is the free tools actually. So you can use it, download it in website. So here, if you can see, it brings not only the geometry element member, but it also brings the loads. Okay, so these informations can be useful depending on where will you use it? Let's say for the open buildings with the BIM modelings, you're not really use the loads, so it will just taking all the geometry. But if you are trying to transfer it to the Plaxis for the connections analysis, and then of course it brings the load for you to do the process, right? And if we have a look a little bit more details on how it looks like the ISM file that we have export from start. So I'm trying to open it with the iTwin Analytical Synchronizer. Again, this is the free viewer for the ISM file. And you can see here, it lists out the objects that already exported. And then if you can select one elements, okay, it show you what is the load resistance, type of loads, what's the axial behavior, and also the details, the materials as well. So this interoperability file, it's very useful when you do the interchange between your teams. If you have like a geotechnical engineer doing the job for the foundation analysis, you can bring or give them this file for structural, and also for the connections, RAM connections as well, for the detail connections, you can bring it as well. So this is how the ISM file looks like. So if I check again, after we already export the ISM file from the start, and we are trying to use this file to develop our submissions for the IFC-SG using the open buildings. So how to do that? Of course, in open buildings, under the analysis tab, we do have the iTwin services or ISM repository. So you can just click by pull the file from this ISM. So pull the file, just selecting the file, where did you put it when you export it from start. Okay, trying to extract this file. And then if you can see here, it note or capture also what is the change management. So it's showing me that this file previously is exported from start by who, which is by me. And then it will map us all the elements like concrete, steels, what's the beam, slabs, columns. And then we can decide to import it, and we can mapping all the elements later on by looking into, again, checking into the iTwin Analytical Synchronizers. You can see here, I try to accept all the elements. I don't want to lose any data. So it brings only the geometry, not the loads, because this is for the BIM modelings, not for the RAM connections, for the detailing connections, or for the Plaxis for the analysis foundations. So now, if you can see it, we can see the mappings. We can confirm all the section mappings, and just taking some process to bring all the data inside open buildings. Now you can have it inside the open buildings. So make sure all the process successful. If you have some error, and then you need to redo all the process to import it. And if you can check from the file that we already imported into open buildings, so we can have like intelligent models that we can use for our submissions. So let's have a look to verify it. First, maybe yeah, we can try to select check the informations. So it looks like if I over my mouse, and then it looks like there is a information for each elements. So if I'm trying to look into the element info, and then we can see it's also populate all the informations that are ready to be key in, also the SG IFC-SG informations. If you see here, there is IFC-SG columns, reinforcement, blah, blah, blah. So all those things can be key in. So this like raw structural from start that can be used later on for our submission. So we can check also the schedules. So automatically it can populate the schedules depending on our mappings before we export it in the previous steps. The beam concrete can populate also the information as well. Okay. So in the next step, I would like to show on how we can do the submissions. So first of all, you need to set up the level. So of course, you can set up the floor manager here. You can add the floor manager depending on how you organize the level of your building. So I assuming this is like a very fresh open buildings files. And we can select options, modify properties for each element to add or key in the information for IFC-SG, or we can also do the group changing to key in all the SGP set information. Let's say for these columns groups. So we can select them and then click modify properties. And then we just key in all the information of the SGP sets, reinforcements. And another way to do the preparation for the submissions is we can also trying to do later on in the schedules. So at this point, I want to show that all the things that I already key in from the selecting and modify the properties, now it's attached to the structure elements. So this is the third steps you can do. You can just trying to go to the schedules. And if you see here, this is the default informations that not contains the value of the IFC-SG. So what we need to do is we try to key in all these value to the elements. So I'm trying to create a new schedules. Let's say, give example for this column stills. Create the schedule properties here. So I would like to go to create this changing for the input for the IFC-SG in one time go. So I would like to select my column steel catalogs. And then for the properties, of course, I select the SGP sets, column dimensions, column reinforcement, and whatever applicable for us for the submissions for these columns, steel columns. So depending on which catalogs that you want to export, then you need to choose appropriately. Okay. So you need to choose the proper properties that you want to add. And once you populate all this informations, I will try to show also on how you can get the one-time goal on the key in all the information for the IFC-SG. So you can organize the schedule. So this is new schedule for my steels. I just want to see what's the section name and then what is the SGP sets. So this is more easier, just showing what I need to key in. So let's say I want to have the SGP set starting story for these columns. If you know that all of the information is the same, you can just select all and key in one and one row, and then it will update it automatically for all. But if you know there's a difference, you need to select it in the groups or one by ones. So you can do this preparation through the schedules, or you can also try to do the Excel exchange. So you can export this schedule to Excel. Okay. And then from this Excel, you can just key in the informations for the IFC submissions. So if you are more comfortable with working with Excel, yeah, it's good for you to work with this Excel exchange and save it. And then from the schedules, we can update from Excel. So just looking for the Excel file that we have opened. And now you have it changed all 45 rows there. And then all the information that you already have in Excel now can be attached to the elements. So if I'm trying to selecting one still columns to check if the information is already attached, we can verify it here. Okay, looks good. So this is just only one or two elements that for the demonstrations on how you can prepare your structural for the submissions. And of course, after you finish for your beams, for your slabs, or for the walls, you can just export the file IFC and then set up the IFC full. And don't forget to sign the level and then just export it. You can select where you want to save the IFC file for the submissions. And it's taking some process depending on the how you big size of your models. So checking every the warning or error. So it looks like this rendering warning. So it's not have to do with my models for the IFC submissions. So I would like to check the result. So this is the file I'm using the beam visions to view it. Okay, so at this point I'm trying to open my existing file for the IFC. Okay, so we can see verify the level works depending on how you set it up. And also, if we trying to select like one columns here, and then it attach also the informations for the IFC-SG, the SPZ dimensions, reinforcements, structural load, it's all there. So that's how you can work with that. I can check another columns. Okay, has also the SG presets for IFC-SG. Okay, and then that's how we can interoperability, how we can share the file, how we can back and forth from start and from open buildings. Of course, as a structural designer, you need to have the detailings. We can just go for the detailings. The same things we can do is we have the pro structures. So this is the pro structure file. We do have the ISM also here, ISM tools here, so we can import it. So the process similar on what we have in the Start Pro and also in the open buildings. So once you set it up, all the mapping sections, and then well, now you have the file. Okay, so it's pretty seamless connections. So if you do have any change, like you want to change the size of this beam, you can just change it in Pro Structures, and then you can export or update the ISM file from here. That information can be bring into open buildings and also in the start. So this is two-way directions. So they can read and communicate each other. But the information that can bring through is depends on where you want to use the ISM file. Let's say if you export from start, it brings the loads. But when you open with open buildings, it doesn't bring a load because this is not for the structural analysis. But the load can be read into the RAM connections or plexes for the analysis. The same also with the structural detailings for pro structures. It just brings the geometry and all the structural data without any loads. So a bit further info for the pro structures. Of course, this is our products for detailer modelers. So we have the concrete with many type of custom or set up for the concrete shapes. And of course, it adopt with the worldwide rebar standard codes. I believe this is depends on the country where you when you work, then it's different rebar codes. And of course, the infrastructure, we do have not only concrete, we do have the steel detailings. So for the connections, also for the connection for the substation structure, for the industrial structure, you can do it here. And for the detailings, you can produce also the drawing reports, like for the fit for your CNC machine in the fabrications. You need some NC data, we can export it from here. So you can just import this NC data later on as input for your CNC machine for cutting on drillings. And we can also create or generate the drawings, which is this like LOD 400s, I mean high detail standards, with all the details works for steel and also the concrete. And of course, with the concrete shapes reports and also the bar bending schedules, all the part lists for the concrete and also for the steel. So I think that's all I want to show on how we can work inside Bentley, and hand it over to you, Vanessa.
Thank you, Juniors. All right, so what Juniors presented was a stat and open buildings integration, and also together with pro structures. And the export from open buildings to IFC, the export to IFC is through open buildings.
Yes.
And you know, in the future lineup of the BSS, the buildingSMART Singapore's BIM Interoperability series, we will be exploring the Bentley environment in further detail. So keep a lookout for that. We'll be getting, you know, more information on how the exports can be done and take you through a step-by-step process. Now, if you're staying with us so far, thank you very much for doing that. We have our final presenter for the afternoon, and that is Vimal Kumar from Graphisoft. Now, Vimal is in charge of customer success, and he takes care of all of our Singapore's Graphisoft customers to use the products to its best potential. Now, Vimal uses things like, you know, Archicad, Solibri, Revit, and Tekla structures as well. But, you know, one of the things that he's going to show us today is how you can bring in data into other products, you know, under the Nemetschek brand as well, which you can then integrate with Archicad under the file format, structural analysis format, or SAF. Now, Vimal is going to tell us more. Vimal, please, over to you.
All right. Okay. Hello, everyone. Thanks for joining. So in the next few minutes, I'm going to show the Graphisoft workflow for SAF. SAF is structural analysis format, and to how to bring those information for exporting the IFC-SG file format. And the agenda is to introduce to you guys the Nemetschek and Graphisoft portfolio, and then we will see the workflow itself. And from the workflow, how we are going to generate the structural BIM model. So we are not going to recreate the structural BIM model from scratch. So we are going to use the architectural model, and from that, we are going to generate the structural BIM model. And following that, we will have the structural analytical model generated inside Archicad based on certain rules. We are going to see how to do that. And following that, how we can export this structural analytical model, and then we can perform structural analysis in tools like Skia, ETABS, and so on. And then we can bring back the information that we have changed inside those structural analytical tools, and then export the IFC model from Archicad as an IFC-SG file format. Okay. So here is the Nemetschek products that we have under the Nemetschek umbrella. So if you see under the planning and design group, we have Graphisoft and Solibri. We might have heard about the other tools as well. And we also have the engineering tools to perform structural analysis like Frilo and Skia. So probably here today, I'm going to show you Skia and ETABS for performing the structural analysis based on the model that has been created inside Archicad today. Okay. So just going into the product ecosystem of Graphisoft, we have Archicad, which is our flagship product for BIM authoring. So Archicad itself can do one integrated model where multiple disciplines can work on the same model and then collaborate and coordinate together. And then we can also generate the structural analytical model based on certain rules, which I told earlier. So this structural analytical model can be exported to tools like ETABS, SKIA, using the SAF file format. And then we have the other functionalities like built-in communication tool to chat with the modelers within Archicad. And we also have model compare tools. So this is not just for BIM model compare, it can also be used for structural model compare. So if you have two different structural analytical models within Archicad, you can compare the difference between the two. Say, for example, if you have edited some of the things and you want to compare between the two versions of the same model, you can compare and then you can see what exactly has been changed in color coding in 3D as well. So after you did the comparison, if you want to create issues, issues can be automatically created. So the issue elements will be automatically added to the issues, and then you can export it as BCF file format, which can be imported in any IFC viewers or any viewer that is having BCF interoperability. And then we also have BIMX, which can be used for viewing the 2D content and 3D content from anywhere. So you can view your Archicad model published into BIMX using any mobile devices, and it is very useful for eyes coordination as well. And you can use virtual reality with Google Cardboard to just place your mobile phone inside the Google Cardboard and you can enjoy the virtual reality. And we also have BIM Cloud, which is the repository of all the model information and also the project information, which can be shared across the project stakeholders, depending on the access rights that they have inside the BIM Cloud. Okay. So here is the Graphisoft workflow that I was mentioning for structural analysis. So we have the Archi model. So the architectural team can create the Archi model inside Archicad. And once they have created the model, the structural model can be generated by just stripping off the finishes and then the unwanted architectural or MEP elements by just showing only the structural part of the architectural model. So this can be done using partial structural display, which I'll be showing later. Once after your structural model is generated, the next step is to generate the structural analytical model. So this again can be generated using the rules that we define inside. And following that, we can export the structural analytical model and then import it inside tools like SKIA, ETABS, and so on. There are a lot of tools which can handle this SAF file format. But with SKIA, we have direct connection. So if you just open inside Archicad and then choose the option to open the model inside SKIA, it will directly open the model in SKIA by just one click. But with tools like ETABS, you have to export it as an SAF file format and then you have to import it inside ETABS. And then once after you have generated the model inside the structural analytical tool, you can apply loads, you can perform structural analysis. And if in case you change anything inside the model, the 3D information of the model has been changed, you can just bring it back in the same SAF format inside Archicad itself, which is a two-way connection. So if you do any changes, it can be brought inside Archicad model. And if you want to compare the changes, you can just compare. And then if you want to accept, you can accept. Or if you want to reject, you can reject. And then have the previous model. So the workflow is two-way here. And once your structural analytical model is there inside Archicad, your structural model is also updated. Okay. So once after the structural model is updated, if in case you want to add the IFC-SG config files, which is for importing the properties and classifications, and also the IFC-SG translator, you just have to import all of them inside. So we have developed a special plugin for importing this config files in a much faster way by just few clicks. And then it's hassle-free. And then once after you do that, you can populate your model information inside the structural model. And then it can be exported as a IFC-SG file format. And then you can view the IFC-SG file inside Solibri anywhere, which is a view viewer. And you can check for the information before you go for CORENET X Submission. Okay. So let me go further. So let us see how to generate the structural model from the architectural model. So this structural model is not developed from scratch. Almost 80% of the structural model has been developed or is retrieved from the architectural model itself. Okay, so you can see here the workflow. The architectural model, when you use this core of structural load-bearing elements only, it will just simply turn off all the finishes and then the other furnishing elements and so on, and then it will just show you the structural model. So thanks to Sabana Jerome for using this workflow. almost 80% of the structural model is coming from the Archi model itself. So we are not developing the structural model from scratch inside Archicad. And we just have to add in only those elements like piles and then the roof structures and so on. The rest, all of them are coming from the Archi model itself. So whatever changes they do, it gets immediately updated inside the structural model also. And there is a shared access for the properties. So both the structural and architectural model will have access to these elements, and then they'll be able to access and then do the changes if at all required. So let us see this in action within Archicad inside the architectural model, right? So you need to go to the settings of that element, and then you need to turn on this structural function as load bearing element. So this is for a slab. So similarly for a column, we have the same set of features, and then you need to add in those structural function there to make it a load bearing element. And below that, you have the structural parameters that if in case you want to edit, or if you want to keep it as default, you can just have it as default. So for example, if you just have it as default and export to ETABS and Skia, and then do the check there, and then if you bring it back the information, this information will be populated back from Skia itself. Okay. So let us see that in action inside Archicad. So you can see here I'm selecting a slab, and then go into the settings of the slab, and then you need to make sure that the structural analytical parameters is set as load bearing. These information can be populated if in case you want to do it here, or you can just get it from Skia itself. Once after you do this step for all the structural elements, you just have to go here to the quick options toolbar and then choose core of load bearing elements only. So you can see here by just few clicks, your architectural model is converted into a structural model, and you just have to add few structural related elements if in case you have any. Okay. So once after your model is converted into a structural model from the Archi model, the next step is to generate the structural analytical model. So let us see how to do that. So you need to predefine a set of rules inside Archicad so that your the structural model can generate the structural analytical model based on this predefined rules that we have. So you can see here when a slab and a slab meets, and there are options to have offset. So if there is a drop in the slab within a certain limit, and if you don't want to have that drop inside the structural model, you can just use this offset option, and then you can just make them as on a single plane. Okay. And similarly for wall-to-wall connection, you can see we have stretch and cut back. So if the wall-to-wall connection, there is any stretch and cut back, you can do that. And column to beam connection or beam to column connection, you can just have all these settings predefined, or the rules predefined, so that the model is generated according to all these predefined rules. Okay. So let us see that within Archicad. So here you can see the structural model is the rule is imported inside. So you can just export and import it from any model. So once after you import in, you just have to key in those values according to the requirements. So once after that is done, the model will be generated. So based on these rules. So here you can see if a column and a beam meets, you have options to one to each other or one to one another options here. And if in case you want to have a specific criteria for a particular element, how the structural analytical model has to be generated, you can predefine that criteria using this settings here. So you can have a specific criteria as well, or a very generic criteria as well. Okay, and we have options for end release and edge release, and then the openings. So once after you do this, you just have to turn on the structural analytical model feature there. And once you do that, your structural analytical model is generated based on the rules that we predefined already. So you can see here for 2D elements, we have a plane, and for 1D elements, we have just one line. And you can see here all the connections are perfectly done. So if the connections are perfect, it will be green in color. If not, it will be red in color. So just imagine if we delete all the rule sets here for the structural model generation, you can see the connections are not perfect. So based on the connections rules that you have, the connections will be automatically cleared. So you need to have a proper structural analytical model generation rules, so that your model will be perfect after you do the structural model, the structural BIM model. Okay, so I'm just trying to re-import the rules, and then you can see immediately how the structural model connections are properly cleared based on the rules that we have. Okay, and if in case you want to see the physical model, the BIM model transparent, you can see as well. If not, you can just turn off. And we can also see the edge releases if in case we have any. And if you want to see the local coordinates, you can just turn on and see the local coordinates as well. Okay, and also the loads can be visualized, but in this project, I don't have the loads. So the loads are not visible. Okay. All right, let us see the next workflow where the structural analytical model is exported from Archicad and then it is brought inside the eTabs. So let us see how it works. So, but before that, you can see these are all the tools that can work with Archicad to import and export the SAF file format. So we have Prepare Structure, we have Skia, we have Reza, Freelo, eTabs, and so on. So if you're using any of these tools, you can just export the SAF file format from Archicad and then import it inside these tools and then perform the structural analysis. And then if there is any changes in the model, you can just bring back those changes inside Archicad by just importing the SAF file format. Okay, so the SAF file format was developed by a Namashek group to establish the collaboration between the structural engineers and then the BIM modelers. And it is an open Excel format, so it is very human readable. So if you export, you can just go in and see what exactly you're exporting. And if in case you want to manually do any changes also, it can be done because it's just a simple Excel format, which will have all the model information there. Okay. So let us see that in Archicad. So you can just open the model. So this particular model has all three disciplines, structural, MEP, and Archi. And after you generate the structural model, you can just export it to SAF file format. So you can see and turn off the transparent model. Let me fast forward a bit. All right, so here's the export part. Yeah, so here you can see we are exporting it to the BIM cloud. So if you want to share it with someone who is using BIM cloud, so they, depending on the access types that they have, they'll be able to access this SAF file. Okay, so you can go to eTabs and then open an empty file and then open the SAF import and export plugin, and then you have options here to choose the files or the element type that you want to import. Okay, so you can either choose all elements or you can choose only a group of elements. Here we are choosing all elements and then selecting the file and then just click import. So once you import, you can see here the model is here. So you're not developing your structural analytical model from scratch. You just have to apply to loads and then perform the analysis. And if you check the properties here, all these properties are brought from Archicad through the structural analytical format. Okay. All right. So when you want to do model checking within Archicad, right? You can develop the interactive schedule and then you can do the model checking when you're doing the modeling itself. And this is very useful. You need not export the model into a third-party tool or any other tool for doing the model checking. You can just do it within Archicad with just the features that are already available. And use based on the IFC-SG requirement. Solibri offers, you can use this Solibri data connection to perform a comprehensive model checking, not just check as well. And then you can perform and then bring back your Solibri inside Archicad using the direct connection. Or if in case you're using Solibri anywhere, you can use it for visual checking and also to check visually based on what from Archicad as well. Okay, now use bring back information from Skia and ETABS in Archicad. So what you need to do that for that is first you have to create a schedule. This model. So you can see here I'm importing the XML file using a plugin typically. So you can just import everything in. So all the prop classifications are inside already. Okay. So here I'm using the translators to import in. Okay, so once after the translators are in, you will be able to see all the IFC-SG related presets there. So now if I go inside any one of the elements, so you can see I'm selecting a column. You can see all the SG preset properties there. Okay, so here you can see I've created a schedule. Right now, all the SG preset parameters that I have listed here are undefined, so there are no values there. So if in case you want to populate these properties, you can just change from here itself. So if you're using Archicad to edit the properties, you can just directly change from here. But if in case the structural engineers are giving you these properties values from any other tool, right, you can export this as an Excel and then you can just import it back so that the information will be populated. Okay, so let me just show the steps to export the Excel. So once after you export, you can just open the Excel and then you can populate the values here. So right now all the values are empty, but I'm just entering the value for one of the columns and then I'm going to import it back. Okay. So here choose the Excel file that we edited just now, and you can see there is the list of changes that is there inside the Excel, and then you can just choose which one you want to import in. So right now I'm choosing everything and then just click import. Once after it is imported, it will just go and populate this information into the column that we have edited the properties for. So I'm just selecting the column from the Excel sheet to highlight it in 3D view. And once after I go inside the settings of the column, I can see all the changes that we imported in from the Excel itself. Okay. So once after your data is populated in, the next step is to export to IFC file format for IFC-SG submission. So just go to Save As and then choose IFC here. And then make sure you choose the right translator. Here we are exporting only the visible elements. I'm choosing the IFC-SG translator and then click Save. So once after you save, you can open it in Solibri anywhere. So it takes a few minutes or a few seconds to save the IFC file. Once after it is saved, here I'm opening the Solibri anywhere. Okay. So right now the interface here is Solibri Office, but it looks very similar for Solibri anywhere as well. So you can just open the IFC file that we just exported and then use the structural discipline. And then here you can see the model. And if in case you want to check the information that you want to export, just highlight the element and then go to the other properties under info view and then choose SG preset column reinforcement that we just populated using the Excel file. So the information is here already. Okay, so this is how you can do the information export from AutoCAD and then export it to Solibri for viewing it or do any visual check as well. Okay, so if you want to understand this workflow in a much detailed way, you can just scan the QR code that is shown here. So we have done a webinar showing all the details of the workflows, including the model checking part using Solibri, graphic overrides, and also the schedules. So everything is shown together. With that, we have the toolkit that we released last time. So the toolkit is very useful for developing the Archicad model and also to populate the IFC-SG parameters. So let me just show the toolkit from where you can download the toolkit. So inside here, we have the updated libraries for Archicad and also the add-on that can import the IFC-SG properties and classifications in a much faster and easier way. And we also have the latest config files. So we have updated the config files for Archicad to the latest industry mapping released by BCA. And you can just download this from the QR code here. And also there's IFC-SG template. So if you're not having any company template, you can just use this IFC-SG template to develop your model. So it is compliant to all the local standards. And then you can develop the model for all three disciplines. And as I told earlier, we have graphic override templates, schedule templates, and then the Solibri rule sets check against the IFC-SG model. So you can just download the template and then you can watch the webinar that we shared earlier. And you can learn how to use this toolkit to comply to the IFC-SG standards. And if in case you have any questions, you can contact any one of us regarding the IFC-SG workflow to perform inside Archicad. So we are happy to help you guys. Right, so with this, I've come to the end of my presentation. Over to you, Vanessa.
All right, thank you very much, Vimal. And of course, the Archicad to IFC workflow was covered in the second episode of the buildingSMART Singapore's BIM Interoperability series. You can find it on our YouTube page. It just happened last week, so it's not uploaded yet. But of course, when we do upload it on our YouTube channel, we will give an update on our LinkedIn page. So please also follow us there. All right. We've come to the end of the webinar session now. Thank you to everybody who have posted questions. If you are still hanging around, if you've got more time, and you want to put a question forward, please go ahead to do so now. Otherwise, I would like to invite you to give your feedback. Right, using our survey feedback page. So I've already put a link in the chat box that you can find, or you can scan this QR code to find us, to find this survey feedback form and give your feedback. And that helps us to put together a better content for our future webinar lineups as well. All right, so again, a recap about buildingSMART. We are an open, neutral, not-for-profit organization, and our mission is to create and adopt open standards and solutions so that we can maintain interoperable and collaborative environment for the digital environment. I'm Vanessa from AcePLP, which is an organization member of buildingSMART. You can also join buildingSMART to learn and grow together with us. We are going to be rolling out more content covering open BIM tools, how you can use the open BIM tools created by buildingSMART to facilitate your open BIM workflows, with IFC being the central file format to capture data in an open BIM format. All right. So thank you very much for staying on together with us. Okay, so I invite all of you to join us at buildingSMART Singapore. We've got, Graphisoft, Autodesk, Bentley, and Trimble. They all are organization members of buildingSMART as well. If you are a software company and if you've got products to share that talks about the open BIM workflows, please also join us to present your content. All right, catch you at the next episode. Goodbye.